Good morning. As I said, I'm Matt Wilson from AECOM. I usually talk on things like building regulations and sustainability in general, and I've got a very specific title this morning on embodied energy, and I've said it's embodied energy, embodied carbon approach, and traditional buildings. And I was thinking, well, what are traditional buildings? Probably these aren't traditional buildings, even though I put them up there, because some would say that would come under a sector of historic buildings or heritage buildings. Some of them have been refurbed, some of them have not. But the idea is we're looking at things that are already there, as are all of these buildings. But these are newer, perhaps traditional office buildings, all in the centre of London. And we can look at various different sectors on whether it's a health sector, an education sector, and particular characteristics of types of buildings, which all have not only the operational energy, but what I'm going to be focusing on is that comparison back to what is actually the embodied energy within that system. And the first speaker we had in the session before said, well, he was going to ignore essentially embodied, he was going to ignore operational, he was going to ignore everything other than the idea of it saying how much is it actually using for just perhaps regulated loads or lifestyle parts of it, but it's not looking at decommissioning. A lot of people say that when you come to things like embodied energy, you're looking at cradle to grave or womb to tomb. It's a thing from right at the very start to right at the very end, and it's something that's very, very difficult to quantify. But there are procedures in place of saying about what should be in the process and what is outside of the process in terms of that life cycle assessment. And we often talk now about life cycle. We talk about whole life cycle, we talk about procuring things based on life cycle, or we talk about sustainable procurement, which is saying it's not just about the small bit that concerns us at that point in time, but what has actually gone into producing it. So it's the manufacture of it, the use of a building, then ultimately the disposal. And when you come to the manufacture, that is changing every minute of every day of what the embodied energy is within any given material. So that's why I think one of the speakers, the middle speaker on the session before him, says, well, it's very difficult to know exactly what any embodied energy is in any existing building when the methods of construction are so different to the way that we're constructing now. But there's certain key principles that you've got to look at. And one of them is saying, well, what is the proportion of embodied to operational? And traditionally, the operational side of what we're using in building has swamped what is seen as the operational. But in our quest for zero carbon buildings, which are based on operational, the embodied energy part of it is becoming a much bigger section, because if we get down to zero, all the carbon in it would be embodied carbon. So how do we actually deal with it? Also, the time that you're looking at the building. Again, in the session earlier, they had a 100-year life. A lot of people are looking at 25 or 50. Not everyone would look at a 100-year life for a building and look at the breakdown. But typically, and it varies on every type of building, and particularly whether you're an intensive energy user, these figures here are actually taken from some typical schools on a 25-year life and a 50-year life. And that has the embodied energy between 14 and 24% compared with the operational of between 76 and 86. But if you dealt with a data center with very, very big loads in it, essentially the embodied carbon might only be 2 or 3%. It could be incredibly low just because the operational is so high. You can get charts that show you historically the effect of, based on a baseline of the embodied energy for a product. This one is looking at cement, but you could look at it for steel, you could look at it for aluminium, you could look at it for glass, any material out there you could look at, well, what is the emissions in terms of the embodied energy within cement? And the change will come about because of the fuels that you might use. Is it driven by gas? Is it driven by oil? And the actual carbon intensity of our electricity supply varies all the time, particularly on when you're actually manufacturing it. So we've got charts that can track things, and you'll see variation over time. But if you look at any one given material, I've got quite a few more of these charts later on to give you a review of it for the most common building materials. The research that has gone on, you get quite a lot of scatter. So on the left-hand side, it's there, the embodied energy in terms of megajoules per kilogram of material. And it's looking at various sources of data for stone and plotting it on the chart, which on there goes from 0 at the bottom to 16 megajoules per kilogram. That's quite a low scale if you compared it with something like aluminium that could go up to 400. But even within that, there's no consistency in approach for stone. And if you get stone, how should you count the transport and the handling costs? I was aware of a project going on in Bath, and in Bath you needed to build with Bath stone. And you could get the Bath stone from a quarry about 2-3 miles out of Bath, but in reality it wasn't just taken from the quarry to the building 2 miles, it was taken to Portbury Docks, put on the boat, taken out to Italy this time, finished over there, brought back actually to Hull, where it had all the fixings put on it, and then put on a low loader and brought down to Bath. So yes, it might be local, but where has it been to get there? And that is true of most glass units, and particularly high-tech new buildings, and what are in the older, still existing buildings. You can say, well, we might have Pilkington doing glass up in St Helens, but most of the units that are giving us good facades are then sent out to Europe, assembled, and then brought back in. So we're seeing a change, particularly in industry in the UK, where we could look at our own carbon footprint and say we're reducing it because of what we're actually producing in the UK. But we're only doing that because we outsource a lot of the dirty industry now out to China and India, and essentially have the cheek to blame them that their carbon footprint's going up, where it's only going up to service our needs in the UK. So what we're using has a much higher embodied energy now to what we might have used just 10-15 years ago, because we've taken the dirty stuff, say we don't want to do it, let someone else take the rap for it, yet we're still importing it. So our real footprint has perhaps gone up. The other big change is where you've got energy intensity, which is looking at what makes a material like aluminium, or you're refining copper, or you're dealing with steel. Now, if we've got a process, and this is out of date on purpose to illustrate a point, I have got it saying what it is sort of this year, but this was electrical generation between 1990 and 2000. And in 1990, only 1% of our electricity was produced using gas. And over the 90s, we had the dash to gas, where we went over and said, what we're going to do is we're going to convert to the combined cycle gas turbines and get higher efficiencies out, to the point that 10 years after, it was 38% from gas. Now, the carbon footprint of electricity dropped from about 0.8 down to almost 0.4, so it halved. So if you've got an electrical process and you're looking at the same way of, say, producing glass, it would have its carbon impact whether it was made in 1990 or 2000. Now, how do we take that into account? We're looking back at these things and we can see it changing with all the researchers who look into it. We've got a very variable energy market, and at the moment the biggest shock to people working with building regulations is we're seeing electricity now being counted as 40% dirtier than it was in 2002, because we've gone back from that amount of gas usage. Nuclear last year closed at under 13%, and nuclear is seen as carbon clean. If you reduce it from where our peak of 25 down to 13, we're only at 6% renewables now, so the renewables have not bridged that gap, so we're getting dirtier in what we're doing. Construction life cycle, materials in, water in, energy in. And at the end, what are the emissions at the other end? Are we contaminating water, air, land? What are the actual extraction materials? How do we do that? Will we have a lower carbon grid? That would mean that electrical vehicles could be seen perhaps as lower carbon. Can we transport in a cleaner way? Can we start using canals? Can we start getting road to rail? And there's a big impact from the government on freight best practice, saying we shouldn't be taking all the materials up and down our motorways as we have been doing, adding to the carbon footprint and the embodied carbon in our buildings. The whole life approach would say, well, right from the start of design, we've got to take into account the materials, the production of those materials, the distribution, the assembly on site. So we can get to lightweight construction, we need less energy to actually put the building up, and therefore if we're using less energy in that process, there's less embodied energy put back in the building. A lot of the tables we see can be very, very misleading. And they're misleading because they talk about it, as I showed you quite clearly, in kilograms of mass of that material. Now, if I'm working with steel or I'm working with aluminium, aluminium gets a big rap against it because it's seen as very energy intensive. But the actual kilograms you're using in your building actually mean that for the same strength and weight ratio, you could be better off using aluminium, which might be 2-3 times dirtier per kilogram than steel. So it's a very, very complex thing. That is true of the material itself, but add to that the distribution, which is much lower with a lighter weight material, and add to that that you haven't got the lifting and you haven't got the mechanical movings on site, it makes a massive difference to what's happening. So the breakdowns that we see there are where is the percentage of the carbon footprint, the embodied carbon, in existing buildings. That's what I've been asked to look at. It's almost impossible to nail it down and say what it was at that point in time. So the norm is, as was spoken about earlier, you usually say, well, if it's existing, we'll take that as zero and work for that. The problem is now with new people doing it, they will say, well, hold on, now from a steel perspective, I think British Constructional Steelwork Association will say 100% of constructional steel now is recycled. It used to be 90%. So what they're putting in is reused. So who should take the hit for that carbon? You building it now, or when it's either reused, which could mean, you know, it's, why have you taken the hit when the next person using it, the next person, and the next person? Even if it was recycled and melted down and reused, if you look at something like aluminium, to go from raw bauxite to then saying recycled aluminium, you cut your embodied carbon in that aluminium by a factor of 20. So how many times is it then recycled, and who takes the hit for what was that so-called embodied carbon? It is not a simple approach, but it's a very important one that we mustn't overlook as we move towards zero carbon. The government is outlining that UK low carbon transition plan. They've set things in place. Paul mentioned, you know, we've got to get an 80% reduction in CO2 by 2050. We're looking at all buildings being what they call zero carbon by 2019, schools by 2016, government buildings by 2018. And the government have got very clearly in place a way of looking at it, and they've not ignored it. All they're saying is it's very, very difficult at the present time to quantify it, and certainly to quantify it with accuracy. But there are key principles that we need to look at. And one of them is this document, which talks about less is more. And it's talking about the business opportunities of waste and resource management. How do we reuse building elements? How do we recycle things actually within a building? How do we actually work? Okay, so I've got an error message come up on here, but you didn't see it on there. And I thought, what have I done wrong? And it's not there, so I think I'm okay. It's obviously got Zebedee disease or something in a moment. Anyway, there are opportunities of how we might use and resource and have greater resource efficiency. Sorry, it did go ping, it gave me a message there, but I can't seem to move on now.
So if you just click back on the screen.
Okay, is that me going off the screen? Sorry about that.
That's all right.
Just a point to get a drink from Paul. Hopefully we're okay now. Some of you have seen these emerging findings. I had the privilege of working on one of the working groups within this on low carbon construction. And again, you can't start looking now at low carbon, that transition plan, without saying it's vitally important that we get material use down, are more resource efficient, are looking totally at embodied energy in our buildings. And it's no good looking at new build. That was made quite clear that we might be renewing at a rate of 1%. So when we get to 2050, 70% of the buildings that we've got now, well, more than that, 70% of the buildings then, which are an increased footprint of buildings, will be what we've got now. So we must reduce it. In fact, any new build is just adding to the problem. You know, you're not sorting anything out with putting up new things and new shopping centres and putting another, 2, 3, 4 million homes up. It's adding to the problem. We've got to sort out what is there if we're going to get to an 80% reduction target. And we've got to look at ways that we might work. So traditional materials, you might say, might be timber. Timber is a pretty good thing. What about dry stone walling? How can we use things? If we go back to the really early days, it wasn't that energy intensive. You might say you could use things like ram earth construction or fox mold construction or the real green eco-warrior stuff. And the eco-warrior movement in terms of building materials seems to be doing incredibly well. But it's not just the embodied energy. As I said, we've got to look at the properties of that materials. How well does that material insulate? How strong is that material per kilogram? Because most of it comes back to things about, well, how does it perform just from one aspect? And we've got to get a bit more holistic in our approach to putting these things together. And there is now plenty of material out. One of the best-selling books within the RIBA for the last couple of years has been the Green Building Bible, which is trying to get a revival in people going away from the norm of, say, most warehouse, probably 90% plus of warehouses are constructional steel. If you look at buildings like schools, the majority of the schools in the north are all steel frame. If you go further south, actually there's been a change. It's still majority is steel frame, but there's more and more concrete buildings because of their worried about overheating, and with overheating the thermal mass argument has come into it. But from a carbon and embedded carbon point of view, is thermal mass a good thing? When you've got a high amount of energy going into the making of cement and into concrete. Now, one of the groups I'm a member of that I just want to highlight as perhaps being worthwhile is the AECOM. And it's looking at construction emissions and trying to get people sharing data on materials and how they perform. And the idea is taking the experience of academics, researchers and construction industry to get more rigour in how we put forward information that can be used to calculate the effects. And that is all part of trying to get an overall building that has been touched on before about reducing our need for energy in the first place, using any energy we've got more efficiently, and then putting renewable sources on it. And one thing that's often targeted at things where people have put photovoltaics on houses or solar thermal is it's okay saving that amount of carbon, but how much carbon went into that wind turbine in the first place? How many years does it take it for that wind turbine just to pay back the embodied energy that's in it in the first place? But certainly material selection is vitally important, and one of the start points in terms of embodied energy is got to be sourcing, and can you have locally sourced materials? If you're bringing materials halfway around the world and you're putting them on boats and transporters, the embodied energy of transport could be higher than that in the manufacture. But back to the life cycle. This is again is based on some schools work and the amount of emissions that we've got within the UK, but the production of materials is a massive, massive load. If you start looking at waste and waste in the construction industry, a lot of the construction industry waste is to do with mining and quarrying and aggregates. If you start looking at that compared with household waste, I think household waste is only something like 9% of all the waste. And yet the construction industry is responsible for about 60% of all the waste. And if you start looking at the waste and the stuff that is there is the byproduct of what we're trying to get, that also has ways of transporting it and disposing of it. So it becomes a very, very complex equation. But in general, people will give you a list of whether it's a high embodied impact or a low embodied impact. And if you use things like NVEST, it will tell you, if you looked at a window, it will say, well, the worst windows, I don't necessarily agree with it, but the worst windows are aluminium, and after that it's UPVC, and after that it's steel, and after that it's hardwood, and then it's softwood. A clear category in terms of eco points about what is the best window. And yet now we've got windows that are UPVC that are A-rated. And the main reason for that is the technology change meant they would have said 10, 15 years ago, you don't want to touch UPVC because it's not recyclable, it's got a life and you won't get rid of it. Now it's one of the most recyclable products that are there, and it's reused and it's reused and it's reused. So our thinking as people changes over time, along with the data that we've got to work on changes. Well, I do know, I spent 3 years working on the Foresight program on materials with the DTI. And I used to sit often between a guy between Castle Cement and a guy from Chorus. And they always used to argue which is the most sustainable construction material, steel or concrete. And the honest answer is I still don't really know, because it's different ways round. The concrete guy said, well, all of our steel is 100% recycled. And he was true in saying that. The argument from British Steel, Chorus at the time, was, well, ours is 90% recyclable. And there's quite a bit of difference between whether something is recyclable, that's someone else's thing later on, or whether you're taking a recycled product in the first place. And I say the clearest thing is if you've got virgin aluminium, you'll be 20 times higher than if it's recycled aluminium. And how do you know what you're using? How do you know what the mix was? If you went to St Helens to Pilkington, I mentioned them earlier, they have changed their recycled content in it in about 5 years from something like, the numbers are not exact, but it was something like 17% and now sort of 30%. And with the recycled content up, they can lower the amount of energy they need to actually work with the raw materials. So they're saving in energy phenomenally just by upping the recycled content, as well as saying you're getting a greener product. But the problem is they all say how much they've improved. There's half the embodied carbon now in steel to 30 years ago. There's probably half the embodied carbon in cement than there was 30 years ago. They're now using rubbish, as in car tyres, as a fuel to get those things down. But you don't know where those products are actually coming from when you specify them. You don't know whether the tiles you're specifying are locally sourced or being shipped in from India or shipped in from Italy. But what we do know is there are ways of looking at things that we're doing. So when you look at tarmac, they will tell you about low carbon concrete and how they're improving and how it's coming down. But nothing in those comparisons competes and beats something like this building, which is an existing building now down in Kent, which is made from locally sourced sweet chestnut, forming the main beams in there, and then it's lined with local larch. And it's essentially 80% wood, and the other materials in there are lime mortar and hempcrete is some of the internal bits, but predominantly it's a wooden construction. And that has it locked up. Now, at the Sustainability Awards about a month ago, this campaign for Wood for Good won the best sustainable campaign. Wood costs less. It's certainly in terms of embodied. You're locking up the carbon in that. But who is responsible for that at the end? Will that be reused? Will it be recycled? Or will it be burnt to get the energy out of it and then emit the carbon? What is going to happen to our buildings that are there now if we do knock them down? When it comes to timber, all timber is different, and one of the problems you've got with biomass in terms of heating, people like to think of it as a carbon sink and it's a store, therefore it's carbon neutral. There's not one bit of biomass out there that is carbon neutral. If you start looking at our lifestyle, how much water goes into irrigating these things? How much energy actually goes into water? If you start looking at our lifestyle in terms of what we eat, there are gallons and gallons of water in every kilogram of beef we might eat. There are things that are the processes we don't fully understand. But if you start looking at what you can achieve, there are very, very different numbers depending on what type of timber you use. So you need to get down into that. What are you specifying? Here's a building I had the privilege of working on in terms of it had the largest green roof in the UK at the time. That's it from the outside, but inside it's got massive glulam beams. Now, glulam beams, are they a good thing or not? How do you, at the end, deal with the glues, and how do you deal with the actual processes? But actually, a lot of timber, they're doing a lot of heat treatment on it now to make it more resilient, so it won't rot, it won't need preservatives. So we're emerging with new technologies that make things usually better with a low carbon impact. But the legacy of our existing buildings has often got very high impact embodied carbon, which we've almost said, we'll write that off as we move forward. The best source of information, so I'm often asked to that, I believe, is ICE, the Inventory of Carbon and Energy. This is put together by Bath University, and it has all types of materials, from paints to lino, to rubber, to brass, to zinc, tin, you name it, it's in there. And what you'll find is it tells you almost the number of records that are, the amount of research that's gone on in each product, and it gives you the minimum value, the maximum number, then a standard deviation. And when you start looking at these things, you give up doing any calculations, because is it 0.1 or is it 14? Is it 1.7 or 3.4? Well, that's quite a close one, isn't it? Is it 1.4 or is it 11.7? Who knows? What process was used? How is that actually there? But we've got to consider it, even if it's just to say in general, that is a high impact or this is a low impact. The exact numbers behind it are almost impossible to define. With spreads like that for timber, which again start quite low, they're in the 0 up to the highest one there is 60. If we look at concrete, and that's per kilogram, you'll be surprised to see that that scale there is lower than the one for timber. Looking at cement, looking at steel, which is getting in then up to 80. Then going to aluminium, hitting on 400, but it's that much lighter. Glass. Now, again, some of the rope figures could be from some of the worst performing, not saying they always are, but could be out in India, whereas the other one could be the most efficient plant in Europe. Where are you getting your glass from? Exactly where is it sourced? Because you don't buy the actual glass, you're buying a unit that's been assembled, usually now out in places like Italy, Germany, or Austria. The changing in the way that the energy impacts with the mix of energy supplies that we use and how clean the coal is we might use or how efficient the gas is. So for aggregates, sands and gravels, what we've seen is probably just over a 10% drop in a period of 20 years, but that's nowhere near going to get us to an 80% reduction in our CO2, particularly if we're using more and more materials because we want thermal capacity. Embodied and operational. We've touched on that before. This is a project I'm working on at the moment, which is looking at 5 building types, and it's looking at target zero, how we get to target zero, and where the carbon is within a building. How much is in the windows, how much in the roofs, the facades, the floor. And what you'll see is that most of it is within the bearing structure and in the foundations. Particularly if you're on things like a warehouse, it's nearly all in the foundations, very little of it's above ground. If you want to know more about that in the sectors, there is a website you can go to, Target Zero, and find out more about it. But it's looking at the various elements, the mass of the elements, how they come together as actual units, and then coming up with overall mass of material used in a building, multiplying it then by the CO2 that you've got, and working out where that goes within the structure, whether it's concrete, whether it's steel, whether it's timber, and other materials within a building. So thank you very much for your attention, and hopefully there's something that you might want to quiz me about at the end of the session. Thank you.